have made it necessary to perform complete rehabilitation of the track. The main objectives of the project are complete rehabilitation of the subsoil, ballast cleaning of those sections on a rock base, and finally installation of the new track. During the whole time, all normal traffic must continue uninterrupted on the adjacent track. These are targets that can only be met by fully mechanized work methods using modern track maintenance machines. The efficiency of every work site depends heavily on the quality of the advanced planning. This involves ordering the quantities of material needed, drawing up operation schedules for machines and personnel, as well as coordination of the track contractors and the railway departments. The necessary data and information are taken from geological reports and inspections, and from measuring runs carried out by recording cars, such as the Austrian Federal Railway's EM250 track recording car. The start of construction work on the line. In preparation, all the vegetation along the track is cleared away. New cable ducts are laid, drainage ditches are dug out, and foundations are prepared for the erection of noise protection walls. The first stage of work is the rehabilitation of the subsoil. Here, the ballast and the old formation material are removed completely. After this, the geotextile is laid with a slight crossfall to optimize the drainage. Finally, the new formation protective layer and the ballast are placed in the track. Here, the AHM 800R formation rehabilitation machine shows its flexibility and high productivity. The machine carries out all work processes, from excavation of the old material and recycling, as well as the perfect installation of the new formation protective layer, including the geotextile. Two excavating chains go into action. The first chain removes the reusable upper layer of ballast. The second chain excavates the remaining material. The reusable ballast is carried away on conveyor belts and taken to the crushing plant for processing. From here, the material is taken to the mixer, where it's combined with water and the formation material to produce the sand-gravel mixture for the new formation protective layer. After excavation is completed, the subsoil formation is smoothed. Immediately after this, the geotextile is laid and the new formation protective material is placed. To ensure the best possible consolidation, the water content of the mixture is checked and regulated continuously. Large plate consolidators smooth and compact the sand-gravel mixture to the required level. The installation of the new formation is now complete. All requirements for a perfect formation protective layer have been fulfilled, without having to remove the track and with rail services continuing on the adjacent track. On some sections of this line, the ballast is lying on a rock bed. On these sections, ballast cleaning will be carried out instead of formation rehabilitation. When the bearing capacity is reduced and the moisture content is too high, this will have a negative effect, particularly on timber sleepers. These are the fundamental problems caused by a polluted ballast bed. These problems can be solved effectively and cost efficiently by the application of modern ballast cleaning machines. The RM80 ballast cleaning machine used here is a proven machine that has worked reliably for many years. The excavating chain removes the polluted ballast. An important factor is the exact guidance of the chain with the help of the cutter bar. The polluted ballast is taken to the multiple layer screening unit. In many respects, the clean ballast has a higher quality than the new ballast, and it's also much cheaper. The ballast is returned to the track behind the excavating chain. Now we go back to the section with the new formation protective layer. Here, the new ballast is being placed. The ballast bed will be constructed in several layers, so the first so-called safety tamping pass is carried out at this stage. This is done primarily to consolidate the lowest layer of ballast. On the other hand, it also facilitates the operation of the following machines. A mechanized maintenance train is used for this work. The mechanized maintenance train working here is led by an 09 3X tamping express, which is a continuous action 3-sleeper tamping machine. This is followed by a ballast plough, SSP 110SW, to profile the ballast bed. The last machine in the trio, a DGS-62N dynamic track stabilizer, compacts the lowest layer of ballast. The third major stage of work is now the renewal of the track components. The old rails and sleepers are removed, new rails and sleepers are laid. The newly delivered rails are laid alongside the track using a special unloading device. Before being unloaded, the new rails are connected provisionally by fish plates.